Hello, I'm Dr. Beto, and I'm here to explain you of UPAC. Here is my partner, Dr. Elephant, and he will help me to explain you what UPAC is. Okay, UPAC. First, UPAC is the International Union of Pure and Applied Chemistry, and what it does is to strive to advance chemistry, in part by setting global standards for names, symbols, and units. Right? Yeah. Okay. The deal of naming the hydrocarbons is to give every compound a unique identity which will convey, without any ambiguity, the exact structure of the compound, like methane, CH4. Okay? Yes. Okay, ethane, C2H6. Okay, and propane, C3H6. That are one of the most common hydrocarbons that exist. Okay, thank you.
A hydrocarbon is an organic compound made out of nothing more than carbon and hydrogen. It is possible for hydrocarbons to divide into saturated and unsaturated hydrocarbons by their bonds. Saturated hydrocarbons have single bonds, and each carbon atom has the most atoms of hydrogen. While unsaturated hydrocarbons have double or triple bonds, this meaning they have less hydrogen for each carbon atom. While hydrocarbons are saturated, they can be alkynes with just have single bonds. But when they are unsaturated, they are divided in three: alkanes, alkynes, and aromatics. Alkanes have double bonds, alkynes have triple bonds, and aromatic have house rings. Okay.
Hydrocarbons which contain only single bonds are called alkanes. The first four alkanes are methane, ethane, propane, and butane. In order to name organic compounds, you must first memorize a few basic names that will appear here or here. That's a little table. In general, the prefix part of the name that reflects the number of carbons in the parent chain.
Hi, my name is Andrea, and I will continue this chemistry lesson with alkenes. Alkenes are unsaturated hydrocarbons that contain a double bond between the chain. The formula that has the alkenes are CnH2n. The way to name it is very similar to the alkane. For the alkenes are named with an ending E and E. For example, pentene will be P-E-N-T-E-N-E, like that, with this ending in a specific. That way you can identify an alkene. An example from a chain more larger is that you first need to identify the double bond in the chain, here in the second carbon, and then to name it as alkane. First you notice the parent chain, that is the longest one, that is this one, and then you circle this one, this bigger one, that is apart, and then to name it will be, first this one will be the fourth carbon, that it will be 4-methyl, slash, in the second one, 2, counting the carbons, 1, 2, 3, 4, 5, will be a pentene, and you can see how it's writing here with the ending E and E. And that's basically all about alkenes.
Hi, now we will talk about aromatics. We have already talked about alkanes, alkenes, and alkynes, and all of them are easy to remember because they are very similar between them. But we should not forget that other unsaturated hydrocarbons are aromatics. The term aromatic was originally used because many of the benzene-related compounds known in the 19th century were found in pleasant-smelling oils that came from spices, fruits, and other plant parts. But now, they are defined as anything that has a benzene ring. The benzene ring is a six-sided structure with single and double mobile bonds. The formula is C6H6, and each corner has a carbon atom with a hydrogen attached. Naming aromatics is very easy. If we have a benzene joined with only one compound, as for example in this case chlorine, therefore this is a chlorobenzene. Chloro is to represent that it contains chlorine, and benzene to determine it is an aromatic. Also, if we had a benzene joined with a bromine compound, this is called a bromobenzene. But what happens when we have more than one compound attached to the benzene? Well, in those cases they are named as the hydrocarbons mentioned before. The ring is considered our parent chain, and then we start checking the substituents. In this case, our first substituent is ethyl and the next one is methyl. Then we start counting in a way to get the less possible numbers. In this example we counted like this. So, in this example, this aromatic should be named 1 ethyl, 2 methyl benzene. Remember to separate numbers from letters with hyphens and to separate numbers with commas. Benzene is to represent that this is an aromatic group. But there is also another way for naming aromatics. Do you remember the last example? 1 ethyl 2 methyl benzene? Well, there are prefixes to represent the number structure. For example, ortho to represent the 1,2 distribution, meta 1,3 distribution, and para 1,4 distribution. To explain it better, this last example can be also named as O-ethyl methyl benzene. Now let's see a second example. If we have a benzene attached to two compounds of bromine, we can name this aromatic as 1,2-dibromobenzene. Or, by the distribution of the numbers 1,3, we can simplify it as M-dibromobenzene. Well, now let's have some practice. If we have this aromatic structure, how should we name it? Remember, you can pause the video in this time. Yep, are you ready? Well, the correct answer is propyl benzene. Propyl because it is attached to one propyl compound. Second exercise, if we have a benzene attached to a chloride compound and a nitrogen compound, how should we name it? Also remember, you can pause the video. Ready? The correct answer is 1,2-chloronitrobenzene, or we can also name it O-chloronitrobenzene. Now last exercise. I think this one is a little difficult. If we have a benzene attached to a methyl compound, then to another methyl compound, and then to an ethyl compound, how should we name it? Are you ready? Well, the answer is 1-ethyl-2,3-dimethylbenzene. But why do we name it like this? And why it is so large? Well, in this case, we arrange the substituents in a counterclockwise direction. First one the ethyl, second one the methyl, and the third one the other methyl. So, the first one is the ethyl, then we separate 2 and 3, dimethyl, D because there are two methyls, and benzene to represent the aromatic. We write first ethyl and then methyl because remember that substituents in the name are arranged in an alphabetical order. This was all about aromatics. Hope you learned something new.
team concluded that to know the different hydrocarbons and how are they classified is like very good information, because like knowing how hydrocarbons work, even though all hydrocarbons have the same elements, it's pretty interesting to know the different uses and the different ways they are arranged.
Hi, my personal conclusion about this topic is that organic chemistry is very important and very necessary to understand, and very interesting to know the difference between alkanes, alkynes, and alkenes, to know how to name them and identify them, because it will help us maybe in our future or maybe in the exam. So, yeah.
Learning what UPAC is has helped me to understand better the hydrocarbons topic, and I have learned the importance of UPAC activities in the modern science.
I think knowing about hydrocarbons, what are they formed and how are they divided, is very important, because a lot of things we use in our daily life are made out of hydrocarbons. So if we know what are they made of, we can start making conscious about them.
Organic chemistry is a very interesting topic because of all the different kinds of ways hydrocarbons or other bonds can be created just using organic chemistry.
In my personal reflection, knowing how to name hydrocarbons is going to be useful for us in the next semesters, because in chemistry, almost all the topics are related between them. So, knowing how to name a compound by just seeing the structure could be the base for our future learning.
I learned a lot about what alkanes are and how are they named based on the IUPAC system. What was more interesting for me was learning how do the prefixes affect the components in the chemical reaction.